Alrighty, so in this video, we're going to wrap up area of regular polygons. This is going to take it to the next level, add a little bit of difficulty to it, okay? So make sure you watch this video and then start practicing. So, SOHCAHTOA, we got to remember our trig. So it only works in right triangles. Sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. So we've got that reference angle of 36. Okay, the x is adjacent, the y is the opposite, and always opposite the 90-degree angle is going to be your hypotenuse. So if I wanted to solve for x, what I'm going to set up is cosine of 36 is equal to x over 7. So I multiply both sides by 7. And so x is going to be, and then I plug that into my calculator, 5.663. Okay? To find y, I'm going to use opposite over hypotenuse, which is sine. So I'm going to use sine of 36 is equal to opposite y over hypotenuse 7. So y, I'm going to multiply both sides by 7. I'm going to get 4.114. Okay, just remembering how to use trig. All right, couple important formulas to remember to find the central angle of a regular polygon. We're going to take 360 divided by the number of sides. And the area of a regular polygon is going to be apothem times perimeter divided by 2. Remember that from the last video. All right, so in example 1, in this first one, we're only going to be given one dimension. So we are going to need to use trig in order to solve for the rest of the problem. So here, all we have is that the radius is 20. Okay? But we do know that the number of sides are 8. So the number of sides are 8. So the central angle is going to be 360 divided by 8. Or, oh, nope, that's not right. I did 320 divided by 8. 360 divided by 8 is going to give us a central angle of 45. Oops, come on. 45 degrees. How does that help me? Well, that means that this angle right here is 45. What I'm going to do now is I'm going to drop an apothem. If that sets up this right triangle, the apothem is here. My radius is the hypotenuse, which is 20. Okay? I don't know this side length either, but I know that that 45 degrees is cut in half. So 45 cut in half, that's going to give me 22.5. Now I can set up trig to solve for the apothem and half the side length. So apothem first. A is the adjacent. So cosine of 22.5 is equal to adjacent over hypotenuse. So the apothem could be 20 times cosine of 22.5, which is going to be 18.4 blah, 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 blah. It's going to be a messy number. We want to keep that whole messy number. We don't want to round too early. Okay? Now, we need to figure out what half of the side length is, because if we can find that, we will eventually be able to find the perimeter. So I'm going to use sine for that because the x is the opposite. Sine of 22.5 is equal to opposite x over hypotenuse 20. So when I solve for this, I'm going to get that x is 7.65 blah, 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 blah. What I'm going to do is I'm going to multiply that by 2 in order to get the whole side length. And then I'm going to multiply that by 8 in order to get the entire perimeter. So if I multiply that by 2, the whole side length is like 15.307 blah, blah, blah. Then I multiply that by 8. And so the perimeter is going to be 122.4 blah, 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 blah. Okay? Now, after finding my apothem and my perimeter, I can figure out what the total area is. So the area, recall area is equal to apothem times perimeter divided by 2. I'm going to use my calculator's memory to pull down the entire number, not rounded. Okay, so 18.4 blah 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 times 122.4 blah blah blah. I'm going to multiply those together, divide by 2, and I'll get that the area of the figure, and now is where I can round. Area is going to be 1,131.371. Do I have any units? Nope. Units squared. Okay? So this is, like I said, where it gets difficult because we're going to need to find the central angle, cut it in half, set up a right triangle, and use some trig. Okay? You can also use Pythagorean theorem, remember, after you solve for one of the side lengths. So you could have used Pythagorean theorem after using trig once. That would have worked. Just double checking that it does. Yep. Okay. So let's do the next problem. Not every problem is going to have a diagram. A regular heptagon. Heptagon is going to be 7 side lengths. Okay. We know the side. Seven sides, and we know the side length is 9 units. Well, that helps us out because we're able to find the perimeter pretty easily when we're given that. Perimeter is 63. Helps us out a little bit. Okay, but now we do need to set up a right triangle in order to solve for the apothem. The apothem is always going to be the height. Okay, we know that the side length was 9. Now it's important to remember the side length. Oops, that's really bad. The side length is the entire isosceles triangle. Okay? That's the side length. That's the base for the entire isosceles triangle. We don't want that. We want it just for the right triangle. So what we're going to need to do with that 9 is cut it in half. So 9 cut in half is going to be 4.5. Now we need to find half of the central angle. Okay, so the central angle is going to be 360 divided by 7, which is a messy number. Now I'm going to divide that by 2 because I need to cut that in half. And it's going to be like 25.71 blah, 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 blah. Okay? Because we need to cut it in half because the apothem is going to bisect that central angle. So now is the time to set up our trig. So I'm going to use tangent here. Tangent of 25.7 blah, 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 blah equals opposite over adjacent. After cross multiplying, okay, what I'm eventually going to get is that the apothem is going to need to be 4.5 divided by this messy tangent number. I'm going to plug that into my calculator. 4.5 divided by tangent of that messy 25 point blah number. I'm going to get the apothem is 9.34, so on and so forth. Okay, now I just use my formula. Area is equal to apothem times perimeter divided by 2. So I'm going to use that whole apothem, multiply by the perimeter of 63, cut it in half. Now I can round to the nearest thousandth, 294.347 units squared. Okay, so yeah, that one's tricky. It's tricky stuff. Okay, just make sure you're understanding, and maybe I will go up here so you can see it again. Okay, the apothem bisects the central angle and bisects the side length. So that's important to remember when you're setting up your right triangles when you're doing your work. Okay? Last one, C. Okay, we've got an equilateral triangle in there. We know the apothem is 5. So we can put 5 right in there for the apothem. What we need to do now is figure out what the side length is. So I'm going to draw in the radius there. We need to find this. In order to do that, we need to figure out what this angle is up here. So the central angle is 360 divided by 3. And that's going to give me 120. So the central angle, I'll use the angle sign instead of A. The central angle is 120. When I cut that in half, the angle for my right triangle at the top is going to be 60, which means that this angle right here is going to be 30. Well, this is a 30, 60, 90 triangle, which means I don't need to use trig. I can just remember that to go from the side opposite 30 to the side opposite 60, I'm going to multiply by the square root of 3. So one side length is 5 square roots of 3. To find the perimeter, I'm going to multiply that by 2 and then multiply it by 3. Because when I multiply it by 2, I'm going to get the entire side length. Multiply it by 3, that's when I get the perimeter. Okay? So the perimeter is going to be 30 square roots of 3. 5 times 2 is 10. 10 times 3 is 30. So the perimeter is 30 square roots of 3. Let's wrap this up. So area is going to be apothem times perimeter divided by 2. So 5 times 30, that's 150. Divide that in half. So the area is going to be 75 square roots of 3. If you have something like a 45, 45, 90 or 30, 60, 90 triangle, and I think you're only going to really experience 30, 60, 90s here, you're going to want to leave yours as an exact answer if the directions are saying. If it doesn't specify that it wants exact, you can leave it as 129.904. That is the approximate answer. But if it's asking for exact, then make sure that your radicals are staying true. Okay? So yeah, that section's a little bit harder. That's going to be really important to practice. Make sure that you can set up those right triangles correctly. If you have any questions, email me, let me know. Other than that, that's going to wrap up all our work with area of a polygon.